Okay, so today let us start with our the next topic, that is in the real numbers, that is Euclid's division algorithm. In the previous class we were discussing about the Euclid's division lemma. Okay, and we solved few questions that were based on Euclid's division lemma. Now today let us move to our next topic, that is Euclid's division algorithm. So our today's topic is that is Euclid's Euclid's division algorithm. Now, first let us write down the statement of the Euclid's division algorithm. Basically, what is an Euclid division algorithm? If a and b are two positive integers, if a and b are positive integers, if a and b are positive integers such that a and b are the positive integers such that a is equals to bq plus r, such that a is equals to bq plus r. Okay, then then every common divisor of then every every common divisor of every common divisor of a and b, then every common divisor of a and b is a common divisor of is a common divisor of is a common divisor of b and c, b and r, b and r, and vice versa, and vice versa. Okay, so basically what Euclid's division algorithm states, if a and b are positive integers such that a is equals to bq plus r, then every common divisor of a and b is a common divisor of b and r, and its vice versa is also true. Now let us come to the proof of this Euclid's division algorithm. Okay, so next we can write down the proof. Okay, so let us take, let a and b are the positive integers. Let C be the common divisor of A and B. Okay, let C be the common divisor of A and B. So we can write uh, let C be the common divisor of let C be the common divisor of A and B. Let C be the common divisor of A and B. Okay, that means C will divide A as well as C will also divide B. That is, we can write C divides A. Okay, C divides A. So we can write that is C is that is, if C divides A, then we can write that is C divides A. We can write it like this, and here we can write that is A is equals to C times B. Okay, next C also divides B because C is the common divisor of A and B both. So we can write C C also divides C also divides B. That means we can write that is C divides B, or it can be represented as B is equals to CQ. Now we are given the relation that is A is equals to BQ plus R. A is equals to that is BQ plus R. Okay, since we have used the term Q in this question, so we can change it like this. That is, okay, here we can change. that term, we can change this term by q1. Okay, so I'm writing b is equals to c into q1 and a is equals to cp. So now substituting the values of a and b in this equation, so we will get that is c into b is equals to b into uh, we are substituting the value of b, so we can put here that is c into q1 q plus r. Okay, so we can write from here that is r is equals to that is c will comes out common, that is p minus q into q1. So from here, now p is the constant, q is a constant, so that's why p minus q into q1 is a constant. That means from this equation we can say that from this equation we can say c also divides r. From this equation we can say c also divides r. C also divides R. That means we can say C is also the common divisor of C and C is also the common divisor of B and R. Okay, so that's by this way we have proved the algorithm that if C is the common divisor of A and B, then it will also be a common divisor of B and R. Okay, now let us come to some applications of the Euclids division algorithm. Okay, so it's very important algorithm, that is the first algorithm that we will discuss, that is to find the HCF of the numbers. Okay, so let's try down the applications. Okay, applications. First, let us write down the first application, that is to compute the HCF of the numbers. To compute the HCF of the numbers. To compute HCF of the numbers. Now for this, let us come to let us discuss this situation by one example. Let's write down the we are writing first question here, that is use Euclid's division algorithm. Use Euclid's division algorithm. Use Euclid's division algorithm to find the HCF of to find the HCF of 196 to find the HCF of 196 and 38,318. Okay, now we come to the solution of this question. How we will solve this question? Now let us come to the answer of this question. Okay, here we will apply the Euclid division lemma to 196 and okay, since among these two numbers 38,318 is greater than 196, so what we will do, we will use as Euclid's division lemma. We will divide 38318 by 196. So here we can write that is applying Euclid's division lemma. Applying Euclid's division lemma. Euclid's division lemma. So we can write that is 38318. When we will divide this number by 196, we will get as the quotient is equals to, okay, when this number is divided by 196, we get as the quotient is equals to 195. So 196 into 195 and the remainder is comes out to be 98. Okay, now in the second step what we will do, now the divisor of in the first step will become the dividend of for the next step, means, and the remainder in the first case will be the divisor in the second case. So here we can write that is when we will divide 196 by 98. So when 196 is divided by 98, it is divided by 2. The remainder comes out to be 0. Now the remainder at the stage is 0. So okay, now here the remainder the remainder at the second stage is 0. The remainder at the second stage is 0. Okay, so the HCF of all these, so HCF of these numbers will be equals to the divisor at this step. So divisor at this step is equals to 98. So HCF comes out to be 98. That is the answer. So by this way, that is the application of the Euclids division algorithm to compute the HCF of the two numbers. That was our first question. Okay, similarly, we can solve one more question based on this theorem. Let us write down the next question. That is second question. That is, if the HCF of if the HCF of 657 if the HCF of 657 and 963 is expressible in the form is expressible in the form 657 into x 657x plus 963 into minus 15, then find x, then find the value of x, then find x. That is our question. Now come to the solution of this question. How will we solve this question? Again, by using Euclids division lemma on these two numbers, so we will divide 963 by 657. When 963 is divided by 657, quotient is 1 and the remainder is comes out to be 306. Now in the second step, we will divide 657 by 306. In the second step, quotient is 2 and the remainder is 45. Now in the third step, we will divide 306 by 45, that is 6 times, and remainder in this step is equals to 36. Now we will divide 45 by 36. Again, quotient is 1 and remainder is 9. Now in the next step, we will divide the divisor of the previous stage by the remainder. Now when 36 is divided by 9, that is division is completed with 4 times and remainder is 0. In the previous step, we make one mistake. Okay, here we will put a positive sign. Okay, now in this stage, the remainder is comes out to be 0. So HCF. So HCF of these two numbers is equals to 9, because that is the divisor at the stage at which remainder becomes 0 is the HCF. Now according to question, we are given HCF is expressible in the form of, that is 657x, that is 657x plus 963, that is 963 multiply by minus 15 is equals to HCF of these two numbers is equals to 9. So if we solve this equation, okay, this will convert it into, that is 657x is equals to 9 plus 963 into 15. So from here, if we solve this equation, that is 657 into x comes out to be 14454. So from here, value of x comes out to be, that is 14454 divided by 657. So value of x comes out to be 22. That is our final answer. Okay, so by this way we have used the Euclid division algorithm to solve the questions which are based on Euclid's division algorithm. Okay, that we will solve few more questions in our next lecture. Okay, thanks for today. Okay.